Okay, now we're going to explore hydrocarbons a little bit more with the alkenes. Now, if you remember, alkene, E and E, means there's a double bond. So when we're looking at these isomers, we're looking at right there, where the double bond is. Also, you may remember the word isomer from earlier in the semester, where before we talked about isomers having the same elements, but different arrangements. Well, this is the same general concept, but when we're talking about different arrangements, we're talking around that double bond. So unlike an alkane, where a single bond, here's a carbon, here's another carbon, because it's single bond, they can rotate and spin in different directions, and they can be all over the place. Alkenes, however, are rigid. They're flat. They don't move. So that means if these two carbons are on the top side here, 5 minutes later, they're still going to be on the same side. So if we look across the carbon-carbon double bond, we notice that we have 2 carbons here and 2 carbons here. Think of it as a level plane. They're both on the same side of the plane. Whereas if we put a line through this double bond, one's on bottom and one's on top. They're on opposite sides. These are on the same sides. Same as cis. So cis, same side. Try to remember that phrase. Trans means opposite sides. So if it's on the opposite sides of the double bond. This is just reiterating the whole idea. The cis and trans. Cis, both thumbs are on the same side, whereas trans, one's going up and one's going down. Here's the double bond. This is a CH3 and this is a CH3. Both CH3s are on the same side. So when we name it, there's 1, 2, 3, 4 carbons, so it's still bute. E and E because of the double bond. And that double bond is on the second carbon. But because it's bended on the same side, both of them are going to the same side, we throw cis in front of the name. So instead of it just being 2-butene, it's cis-2-butene. Whereas here, 1, 2, 3, 4, here's our bute, double bond, E and E. It's on the second carbon, so 2-butene. One's going down, the other one's going up, so it's trans. They're on opposite sides. In order to have a cis-trans configuration, you can't have the same side of the carbon being identical. There is no cis and trans here because remember we draw the line through the double bond, not up and down, but from left to right. So we draw it here. This can't be a cis or trans because both these have hydrogens and both of these are bromines. So there's not one that's more dominant than the other. Alright, this is giving you an example, but I'm going to take this example and look at as far as cis and trans. Here's the double bond. If we draw a line through the double bond, you notice that that side goes down, this side goes up. Therefore, this double bond is trans. If we do the same thing with this one, both sides are going below. That means that side is cis. So that the first double bond is trans, but the second one is cis. So both bromines are on the top, so we have cis. One's on the bottom and one's on the top, so that's where we get the trans. Everything else is named exactly the same. There's 2 carbons, and that's where we got ethene with the double bond. There's 2 bromines, So it's bromo. There's two of them, so it's dibromo, and it's on the first and second carbon. Dibromo, first and second carbon. The only difference between these two is one's cis and one's trans. That's making these two isomers. So we're going to name each of these, and we're going to put cis and trans when it's needed. So with this one, A, we have two carbons there. That gives us the prefix of F. It's a double bond, so that's E and E. We have two substituents, they're both bromos. Because there's only two carbons, I'm not going to worry about where the double bond is located. But we do have dibromo here. And then from here, we know it's going to be cis because they're on the same side. For this one, pardon my computer. There's our long chain. There's 4 carbons there, so that gives us bute. Double bond is E and E. That is on the second carbon. Notice there's no substituents here, it's just hydrogens. So we're going to go straight to the cis or trans. This is trans 2-butene. This is 1,2. I forgot the numbers in there. Okay, and then finally, here's our compound. It's prop because there's 3 carbons. E and E because of the double bond. It's on the first carbon. We have 2 chloro groups. And they're also on the first carbon. Now, because the 2 chlorines are identical, we do not have to worry about cis or trans. We only have to do that if they're not identical. For instance here, bromine is on top, hydrogen is on bottom. Bromine's on top, hydrogen on bottom. Those are different. Hydrogen and CH3, those are different, so we need to have the cis and trans. Cis, 1,2, dibromo, ethene. Bute, because there's 4 carbons. E and E, because it's a double bond. That double bond's on the second carbon, and it's going in opposite directions. Prop, because there's 3 carbons. E and E, because of the double bond. Dichloro, because there's 2 chlorines. And 1,1, because that's where the chlorines are. You'll notice that we did not bother putting cis or trans here because chlorines are identical on that same carbon. Right, and that is all of section 2 using cis and trans isomers.